Our next two speakers are Michal Skipala and Bruno Rossi from T-Mobile and the Masaryk University of Brno, respectively. And they will talk about Monolith Splitter, a tool to split monoliths into microservices.
Hi, so welcome everybody. I'm Bruno Rossi from Masaryk University. Like already said, I will be just introducing the first part of the presentation. So what is the idea of this, let's say, this presentation is to present one tool we are developing about that can give us the best way to split a monolithic system into microservices. And it's something we have seen also is very useful for company in our area, and of course not only our area. As you will see, so this is basically just some information about ourselves. So I'm working at Masaryk University. I am of course Italian. Michal, maybe interesting, is full-time working and also doing the master thesis. This is very common there in our university. The students work full-time and also do their studies, which is maybe different than what you have here. And this brings to the idea of having this connection with the companies, and also what are the needs the companies are often needs which are also seen in the thesis work and in the research which is done. Okay, so you can read here a bit about ourselves. I think I will skip it, so just to be shorter. So what is the context of this? The problem, let's say, is that the migration to monolithic systems, as you know, is very interesting for companies. Now maybe there is even another trend which is trying, after companies have migrated to microservices, maybe they try to go back to kind of monolithic system or to modular monoliths, if you know the concept, so which is another interesting part. But here, of course, we are focusing more on the other way around. And as you have seen, probably if you had experience, the migration process is very complex. There are books also we use for students during our courses to show patterns they can apply during the migration, which tell, for example, to split the migration into sub-parts, also how to decide which services to migrate first. And you know, in any case, it's always a very complex task, no, to do the process, because of course you are doing this typically in production, and you don't want to break the production system. So there are numerous ways to split monoliths. Some could be better, some could be worse. Of course, we need some indicators somehow, and also evaluation from qualitative evaluation from the people which is doing the migration. So measuring the final results is difficult. And in this work also we try a bit to take or bridging a bit the research, so algorithms which have been proposed to migrate systems to microservices and try to re-implement for companies also to be used. So something which can show some practical, let's say, benefit to the companies. Okay, so I will give the words to Michal, that will try to explain what is the tool about and how it's working and what is the main idea of work. Okay.
Hello, everybody. So just to quickly introduce myself, my name is Michal Skipala. I'm working at T-Mobile, and I'm also a student working towards a diploma thesis. And this diploma thesis has led to the creation of this project called Monolith Splitter. And as you already heard, splitting a monolith is a very complex task, and Monolith Splitter is a tool currently in development that suggests multiple approaches for migrating the monolithic applications to microservices. And it accepts the execution traces and git log files as input. The execution traces are essentially logs that you capture during runtime of an application in a specific format. And the result is clusters of classes that naturally align with microservices based on the approach and the algorithm behind it. The tech stack is Java 21 on the backend with Spring Boot 3.2, PostgreSQL as a database, and user interface coded in TypeScript and React.js. About the benefits for the open source community, I think it could provide support to software architects looking to modernize their applications and maybe experiment with transferring to microservices architecture. The algorithm implementations will be openly available to anyone, enabling practitioners to leverage this tool across their projects. And I think it can potentially accelerate the modernization of legacy applications. So this is how example input and output looks like. The input is like a timestamp, use case, then the first class and the second class, depending which one is currently on the stack, and the name of the methods. And also, optionally, you can supply a git log file. The git log file is later used to analyze the independence of evolvability, since it's one of the important metrics when you're moving towards microservices architecture. And the results taken from the user interface look somehow like this. So you have clusters and the classes from the monolithic application distributed amongst these clusters. The algorithms behind Monolith Splitter are Mono2 Micro and FOSSKey. Mono2 Micro uses spatial temporal decomposition. It works with business cases and runtime correlations, and it optimizes for four metrics: direct correlations, direct call pattern, indirect correlations, and indirect call pattern. From these metrics, it computes the similarity of these classes, and then uses hierarchical clustering to split these classes into microservice candidates. It was first introduced in a paper called Mono2 Micro, a practical and effective tool for decomposing monolithic Java applications to microservices. And if you want to know more about the implementation details, I have supplied with the link to the research paper itself. The second algorithm behind Monolith Splitter is called FOSSKey, or functionality-oriented software candidate identification, I believe is the full name. And it works a bit different. First, it generates functional atoms, which are like coherent minimal functional units. And it generates these functional atoms using Jacquard coefficient. You supply an input parameter called diff, and the diff basically decides where the clustering should stop. And it makes the functional atoms either bigger or smaller, depending how different to each other should they be. And it optimizes for other metrics, structural and conceptual intraconnectivity and interconnectivity. Intraconnectivity is basically the amount of calls between the microservice candidates, and the interconnectivity is the number of calls inside of the microservice candidates, like class to class versus cluster to cluster. And it tries to maximize the intraconnectivity and minimize the interconnectivity, so there are not many calls between the resulting clusters. And Monolith Splitter implements these two algorithms, and as I said, it's based on the research articles as seen on the slides. And there's also a snippet of the user interface. It's a prototype, so it's not really pretty yet, but we're working on that. And you supply the execution traces, diff for FOSSKey. You also have the expected format, how the looks should look like. And you can also optionally use a git commit log to analyze the independence of evolvability later. The tool has been tested currently on applications JPetStore and Acme. These are widely used sample applications used mainly for benchmarking in research papers, and execution traces for these projects were sourced from publicly available Mono2 Micro datasets. And future testing is planned on widely used monolithic open source projects written in Java. One of the candidates currently is Broadleaf e-commerce. So, about the testing results, about the JPetStore, this is the Mono2 Micro output, and as you can see, Cluster 0 has classes related to cart. As you can see, cart, add item to cart controller, view cart controller, cart item. The cluster 2 is more related to account, so it has classes account form controller, account form, etc. Cluster 3 is cluster related to orders, and there's a cluster 4 with sign-on interceptor as a class that is not really connected to any other classes that much. If we use 6 clusters as an input parameter, as you can see, it's split to the cluster 4, the category, view category controller, SQL map category DAO, and category. In 5 clusters, it remained in cluster 1 along with items and other classes. So if you choose more clusters, you can get maybe a better result, because some classes will get split from other cluster into its separate cluster. This is the test output for Fosky. As you can see, it's vastly different because it optimizes for another metrics, not the same as the Mono to Micro. And what's interesting about Fosky, since it's a non-deterministic algorithm, it means that every result you generate is unique. The Fosky uses non-dominated sorting generic algorithm 2, which is used for transforming the functional units, functional items, to service candidates. So I have some more applications here, Mono to Micro on Acme Air. As you can see on the Acme Air, it somehow successfully split the classes about customer into its own cluster, or auth service, key generator, REST cookie session filter. Everything looks like it's connected to each other. So I think the results are pretty promising. But of course, it's just a suggestion and it's not perfect. So which approach is optimal? It is a difficult question, and the answer depends on what do you want from your microservices. You can either focus on your microservices to be as independent as possible when it comes to development. Let's say your company wants to develop a new feature, and you want this feature to cause changes to less microservices than more of them. Or you can optimize for the performance because you don't want many calls between the microservices, so you use the other approach. And it's planned to add more approaches to the prototype based on other research papers as well. About current limitations and challenges, so optimization of metrics for computation for explainability is on the way. Metrics like intercall percentage, cohesiveness, structural modularity, etc. So you can compare these results and get exact numbers about how good is the split. Varying approaches today require specific input sets. Some legacy projects don't have access to Git logs because they may have been on SVN, for example. Fosky analysis is time-intensive on large data sets. For files that are over 10 megabytes, you have to wait several minutes for the analysis to complete. And of course, capturing quality execution traces is key for the algorithms to work, and it can be a challenge in legacy systems to capture these execution traces correctly. So, thank you very much. Does anybody have questions?
Yep. Can you just wait for a second? We can get the microphone.
How the algorithm decide, or better, how it analyze how to split in cluster the classes? It's based on static or dynamic analysis?
It's dynamic analysis since it's runtime traces which are collected during the execution of the software. So you do some business cases. Let's say you have an eShop, so you add an item to cart and name this use case add item to cart, and you have the traces, the methods invoked in this use case, and it's analyzed based on this. But I think Fosky uses some static analysis as well, as it looks for the name of the classes as well, and it suggests the recommendations also for that. It's the structural inter and intraconnectivity. I mean conceptual, sorry, not structural.